Hey, hey, it must be really, really close to 2 hours UTC. It looks like it's 1:59. Ah, there it goes. Ding, 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 ding. We are at 2 hours UTC. It is time for Astronomy Daily Live. You can call me Cosmic. Just don't call me late for dinner. That's it. That's it. Call me pretty much anything else. Cosmic is where it's at, so that's where I'm going to be. Hope everybody's doing well today. This is Astronomy Daily Live. It's a live stream every single day at 2 hours UTC, where just a circle of friends gather together and talk astronomy for an hour or so. Sometimes a little bit more, sometimes a little bit less. Topics can go all over the place. If there's a nice crowd in here, we can talk about anything you want, as long as that's astronomy or science in general. That's sort of the direction that I like to go. Um, if there aren't any topics with the crowd, I always, right back here, I carry around topics in my back pocket. So I'm going to pull up the chat here to make sure that I'm covering all of that. I'm going to go over to my smartphone and see if I can see myself live. Let's see. How do I do that? There we go. Yeah. Yay. So Astronomy Daily Live. So if there aren't any obvious topics or anything like that, as I said, I can pull things out of my back pocket. That's one of the cool things about astronomy is that there's always something to talk about. Now, Fraser Kane and Paul Sutter today posted a video about sort of the end points of science, and I guess okay, mathematically, yeah, there's a finite number of things, and therefore there's a finite number of possibilities in terms of various um, combinations and permutations and all of that. So yeah, mathematically speaking, there is a limit, but it is so incredibly large that it's sort of like what uh, what the old sages used to say, something like you can never cross the same river twice. And here's here's a case in point. I mean, that's sort of saying that there is no end, right? Because even if you you know cross a river, right, you still have all the flowing water, and uh, that is just a continuous process. And isn't that cool? Isn't that cool that we live in a world, we live in a universe that is as diverse as that. That it isn't just the combination of particles and all of that, but it's also all the combinations of events. And yeah, it just gets absolutely huge. It's absolutely huge. Uncle Bill is in the house. Skylius will be hosting the first robotics competition live on Twitch. Cool. Interesting. Interesting. I'll need to check into that a little bit. It's happening on April 18th. Okay. Robotics competitions. Yeah, mm, maybe because I've never been involved in them. Um, The few that I've seen are sort of like they seem to be sort of like remote controlled gadgets um, that they have some kind of a competition where they either have to fight each other or fight in a crowd or they have to perform a certain task. Yeah, I don't know. I don't know. I guess I just don't find those all that interesting. Um, I don't know. Maybe it's a prejudice of mine. I do have a prejudice against computers, in that I absolutely hate them. so so yeah. So okay, yeah. Gets kids excited about things, and that's all right. That's all right. Again, maybe I have a different perspective about things. Uh, Myself, as a kid, I didn't need any external inspiration to want to become an astronomer. Um, there was nothing around me, right? There wasn't even a good sky as a kid, so I had no external um, inspiration at all. The inspiration that I had came from internal things, just knowing and wanting to learn and do everything I can in terms of astronomy. And, in terms of science, technology, all that in um, general, right? So, yeah, but I think it's cool. I think most people do need some kind of external stimulation, to get them thinking about things. It certainly doesn't hurt. Certainly does not hurt. So yeah, I am completely um, in favor of those kinds of things. I'm just saying personally, doesn't have a lot of value, but I see what the value is to others. And my bottom line is always, if you're having fun and having a good time, then do whatever you're doing. It doesn't matter. It doesn't matter. If you're having fun, then that's it. That's it. Because that's what this is all about. Is to have a lot of fun. And if you can maximize that, then you're doing very, very well. Speaking of maximizing fun, the drink of choice tonight is hydrogen hydroxide. Very relaxing, very calming. Uh, this now this isn't a new batch. This is just the regular old batch. It's good old HOH, and it's awesome. So cheers. I uh, I grew up with Legos. Legos were my go-to toy. In fact, over in my closet over here, I still have those Legos. I pull them out from time to time to look at them, but yeah, they're gonna basically stay in the box. Now, what do I have running here that wants my attention? Apple software update. Do you know what I do to Apple software updates? I hit that big red X in the upper right corner, just like that. I'm having to do it twice, maybe three times. Oh, it wants me to quit, maybe. Wow, it's really slowing down my system. Let me, okay, there we go. Now I should be, now I should be a little bit better. Oh, updates, updates. Everybody wants to do updates. So yeah, I got into Legos pretty heavy with, you know, the limited amount that I had. I probably had uh, maybe 1,000 pieces, maybe not even that many, a few hundred. um, something like that. But it kept me going for years and years and years. Probably a good, I probably had a good 5 year run with Legos, and and maybe this is a bias again, but even at a young age, I appreciated and understood the uh, the value of the universal set, just pieces, not anything specific, not anything custom, just pieces. Because with those pieces, okay, I could create anything, pretty much anything I wanted, and I did. Um, and uh, I I would I was around when they first started sort of coming out with the custom Lego sets, and because I was into space and astronomy, I got some kind of moonscape thing that had pieces to make sort of a simple rocket, and it was the first um, little Lego men um, to come out. So I got those, and they sort of had a moonscape thing, and they had this and that, and then I think I got a couple what I would call models, which were sort of in general sort of specific things. I think one of them was a motorcycle with a um, piston engine, that you had to build. I think it had a motor in it. I think there was another one that it was like a uh, what are those called? The bridges, that lift up and down. I don't know what those are called. Um, but when I saw sort of the more specific Lego sets, I was actually sort of turned off to those because it's like I can really only do one thing with this, and I mean, I guess I can do it over and over and over and over and over, but I guess I was spoiled and or biased uh, to uh, uh, um, see any value in sort of the specific things, and these days I think I need to look into this a little bit more. But I'm pretty sure that you can order Legos online from Lego itself and get whatever pieces you want, pretty much whatever color you want too. Um, and yeah, maybe there is a future uh, in terms of Lego and me. I don't know. Don't know. That'd be an interesting, sort of full circle. Um, there's another full circle project that I'm working on. The second computer that I ever had uh, was a Timex Sinclair 2068. It had 72K, well, a total of 72K of memory. Um, a lot of that was used for video display and, of course, ROM and other things. But I think there was like 32K um, available for user space, and that was a huge jump up from my first computer, which was a Timex Sinclair ZX81 that had 1K of memory with a 16K expansion uh, card of sorts. It was like a plug-in box at the back, and but yeah, uh, so the 2068. In fact, I still have both of those computers as well, right in my closet, and those both those machines use a Z80 microprocessor, Motorola, and Z80s are still used today in a lot of micro devices and embedded devices, that kind of thing. So, these things are um, um, still around. The As a kid, okay, I did not, I did not comprehend machine language, um, and it was sort of a double reason. The the first reason was is that I didn't understand computer architecture. I didn't understand, the memory map. Didn't understand how any of that worked at all. It wasn't necessary. I mean, I didn't really see it as a magic box, but it was just a thing that I uh, never understood, and therefore never got into. Um, and machine language was exactly the same thing. I didn't Because I didn't understand the architecture. I couldn't understand uh, machine language at all, and it was sort of a frustration of sorts because I there were a few games that I bought. There was a flight simulator and a couple other games um, that were written for um, both machines. And when I, you know, these games were saved on tape, cassette tape, and so you loaded them in to your machine with a connector, just an eighth inch mono connector, and so you would type a command on the machine, to load some file name, right? And then you would um, hit enter, and then it would go into this phase, right? And then you would hit the play button on your tape recorder, and sit back and watch the show. And sometimes it took several times, to load properly, some kind of translation error, those kinds of things. But when the program would load, I would look at it, and it would just be this string of symbols, really really strange characters, black boxes with lines in them, just weird shit, right? And so I thought that it's like, okay, well, if I just copy all the characters down, then I could write machine code too. I don't know what it means, but I could do that too. And I knew about, or I was aware of um, commands like peek and poke. Didn't I didn't understand what they did, and I didn't know what I had. Right. So all of my programming, which was extensive, uh, was in BASIC. These machines came with BASIC, and when you turned them on, you had a little prompt that that allowed you, to write um, basic programs. And so that's what I did. Um, I never got into machine language or anything else. But recently, this little thing in the back of my head, right? Sort of like the Legos. It's like you've you've got unfinished 12-year-old um, business that's just sort of a dangling thing out there. The 12-year-old in you is like, finish this, finish this up, figure it out. And of course, now I understand all of that stuff, which makes it much easier, because it's all I really have to do now is sort of get a basic understanding of the Z80 um, uh, um, language, and you know, what things it wants in order to do things. And you know, I've got to have an understanding of the memory map, and you know, how the Z80 processes commands and all of that. But once I do that, I can actually start programming on that machine in machine language. And so yeah, that's sort of a project sort of in the back of my head. Um, and Uncle Bill, you've reminded me about the Lego thing too. So I don't know. I don't know what I would do with Lego. I don't really know what I'm going to do with my Timex Sinclair 2068 either, because you know, I'm not into doing things in sort of an academic sense. You know, doing them just to do them. Not into that. I need how I learn and how I function is I've got to have you know, like an interesting project or an interesting problem that I want to solve. And so, you know, any program that I want to write, I'm going to use my Linux machine over here, and I'm going to write in C, and you know, I can do everything there. Um, so yeah, I just don't know. I don't know what I'm going to do uh, with writing, you know, machine language on an old machine. I don't, you know, there are, you know, hobbyists who still use this thing. So you know, maybe there's, I've got a kitty over here chasing bugs. It's about to become bug season, and yeah, oh, okay, she's seeing some moths on the outside, and she's on the inside, of course. And so she's trying to get them and having a good, frustrating old time as kitties do. All right, well, cool. So, Uncle Bill, you sent me on a tirade talking about Legos and computers, which I don't think have anything to do with astronomy whatsoever, except for the fact that astronomy is a science, and science is very creative, very creative, and um, uh, and so are Legos, and so is programming. So yeah, there is the relation there of sorts. You know, I think I've got something on that tooth. Yeah, it's gone now. My apologies. But when I can see myself on the screen like a mirror, it's like, you know, you start looking for things like that, and you know, they pop out. So science is everything. Well, yeah. I don't know if I necessarily think that science is everything, but science, you know, science to me is a process. In fact, it's what I would call um, a, a process fractal. And I've talked about this before. It's sort of a self-feeding thing, and uh, but yeah, you know, that process can certainly be used in lots and lots and lots of things, pretty much for everything. So yeah, in a certain sense, I, I would say, you know, the process of science can cover everything. All right, well, cool. I wanted to what should I pull out of my pocket tonight? I think what I'll do is, you know, take a relaxing gulp of this wonderful, amazing chemical before I continue. Cheers. Yeah, I never got into the erector sets. That was they were around, of course, when I was a kid, but that was a little bit past my time. Lego was new and really being pushed, and I was totally into that. I fully endorse Lego things, especially the Universal sets. Anyway, I'm not going to get off on that anymore. Um, had a good observing session last night. Still, I'm sort of in learning mode when it comes to this scope. I've had this scope for quite a while now, and uh, uh, until very recently, thought that it was pretty limited, even though it was a major step up in terms of what I was doing. Um, my first scope, which I built, um, uh, uh, has always been, just a looking telescope. It's never been a data collection scope. But I had the opportunity to acquire a CCD camera. So it's like, okay, what can I do with this thing, with the scope that I have? It's like, okay, let's look at the motions and the photometry of the four Galilean moons of Jupiter, because I can take very short exposures because they're very bright, and it doesn't track the sky. So I'm going to have to be, relatively active in terms of making sure, that Jupiter and its moons are always in the field of view, that kind of thing. So I did that. And that's a project that I actually want to continue doing. And I'm probably going to do that once Jupiter is past opposition, which should just be in a couple few more months. Don't remember exactly when that is. Easy enough to look that kind of information up. Um, Mainly, I'm waiting for past opposition, so I don't have to get up in the mornings to look at it. So yeah. I mean, um, once it's past opposition, uh, then it'll be up in the evenings, and I'll have a good 2 or 3 months to observe it, and again, watch the motions of the moons, and also measure their brightnesses as they orbit the planet. And yeah, so that's a project that I'm probably going to jump back onto. As I said, I have another very interesting project in which I need to become intimately knowledgeable about how this telescope functions, what its um, capabilities are, uh, all of that. And by the way, speaking of new projects, here's a headline for everyone watching. I am going to be starting a new project on this YouTube channel, um, maybe starting as early as tomorrow, but definitely starting in the next few days. And I'm not gonna say what it is at all. You're just going to see a new post on this channel. It is definitely not going to be a live thing. It is going to be uh, well, it's going to be pre-recorded. I don't really. I'm gonna mess with some um, production software that I have, but I'm pretty limited in that realm. So probably it's just going to be a pre-recorded thing, not necessarily produced or edited in any way. We'll see how it goes. It's going to be moderately challenging, but I think I'm hoping what it will do is uh, it'll entice maybe a different crowd that is into science and astronomy, but maybe for one reason or another, isn't really into the live streaming, or for some reason doesn't have an interest in this format. So, which tell me, how do I get a bigger crowd? I mean, I can market a lot more. I can be a little bit more obnoxious. I don't think that's the right term, but I can definitely make myself more visible. Is that what it takes? I don't know. But anyway, so I am starting a new project, science-based, astronomy-based project. So look for that over the next few days. It's going to be pretty interesting, and I hope it'll draw a nice crowd. So cheers. Thanks for hanging in, everybody who is watching. You can be watching this live as it happens right now, or maybe you'll be watching this sometime in the future when it is recorded and set to live stream world. So yeah, hope everybody's doing good. I guess what I wanted to talk about tonight, I I've been thinking about telescopes, and you know, gaining some experience and knowledge with how this telescope actually functions, how it points, how it tracks, and then the quality uh, that I can get out of it. Happy to report, very happy to report that uh, when I have no kind of filtering on this guy, I can achieve 15th magnitude with a 1 second exposure. So I've got a really dark sight, and that makes those kinds of things very possible. So I can see a 15th magnitude star with a 1 second exposure. And maybe if you didn't see them already, I'm going to direct you over to my Discord server, and I'm going to share the screen here. We can move over to my, and you can just sort of see what I'm up to here. So this is uh, a full frame image of a region of M37 that I took last night. So this is reversed. Um, so everything that's black is actually white. It just it oftentimes, seeing a black thing against a white background, the contrast seems to be a little bit better, so the stars pop out a little bit more. But what I'm saying is, and these are still out of focus. I need to work on the focus a little bit here. But as you can see, if you look at these really faint things here, really faint, those are like 15th magnitude stars. And as you can see, they're quite extended. They have like a little halo around them. There's a point, and then there's some fuzz around them. That means my focus isn't quite good enough. I've still got, maybe 3 pixels there, 3 or 4 pixels across. Well, at this binning, this is 1 by 1 binning. I have a pixel scale of about 1 arc second per pixel. And the seeing here is about 1 or 2 arc seconds or so. So I mean, if I were at best, uh, these faint little stars should not have these little halos around them. They should be basically pixel 1 or 2 or 3 or 4 pixels, and that's it, right? And what I'm seeing is many more than that. So I've got to work on the focus. Focus is one of the hardest things to get exactly right. Um, but even out of focus, these really faint dudes here, that's 15th magnitude. So that's just absolutely astonishing that this telescope with a 1 second exposure, right? 1 second exposure no filters, through a 0.2 meter telescope. That's 8 inches, uh, with a secondary mirror that is blocking a substantial amount of the light. Um, with all of those sort of negative factors, the fact that I can see a 15th magnitude star with a 1 second exposure, that's awesome. That's very awesome. So, M37 is actually one of my favorite clusters. I love to look at it. It's got some nice color. There's a lot of, as you can sort of see in this image, there's a lot of stars in this cluster that are basically the same magnitude. So it just makes for a really, really interesting looking cluster of stars. There's one bright one in here, and I think he's pretty red. Don't remember exactly. Don't remember exactly, but it's a very, very rich um, cluster of stars. Several hundred, several hundred stars, I think, are associated with this cluster. Uh, very, very awesome. Very awesome cluster. And just from looking at it here, you're not looking at the whole thing, right? You're just looking at a section of it. But it's a pretty good image. You can see now this is just a raw image, right? This is not dark subtracted. This is not flat fielded. This is not um, biased in any way. So you can see like these bad columns here. You see these bad columns. It's hard to see here, but I'm seeing a lot of like individual black pixels. Those are bad pixels. Those are hot pixels that are either turned completely on or completely off, um, or just super super sensitive to light. So even just a little bit of light, turns them on. But it's a pretty good image for a 1 second exposure. Can't complain about that at all. I'm really really impressed. But as I said, I've got a little bit that I have to learn about this system yet, because I am at the moment I'm going to be limited to about 1 second exposures until I can auto guide or somehow manually guide, so I can do longer exposures, you know, minutes long or hours long. Uh, even a 5 second exposure, I'm just not going to be able to do just by tracking. I have to be actively guiding. So yeah, that's not going to be happening for a while. I tried, but there is, as far as I know, there is no current interface between the the camera control software that I'm using, which is CCD Soft version 5, and my telescope, which is a Celestron Nexstar 8 SE. So until I can uh, either find something or construct something that has, well, that's able to translate the CCD soft commands to move the telescope into commands that the telescope can actually understand, I am SOL on that project. So I'm sort of limited to 1 second exposures. The main project um, for last night's observing run was to take some exposures uh, at different exposure times to see how, you know, can I get away with a 2 second exposure? Can I get, I'm not exactly sure. So I took some exposures at half a second, 1 second, 1.5 seconds, and 2 seconds, just to sort of see. I still need to analyze that data. Um, but I was so impressed with the unfiltered, that this is a full resolution, 762 pixels across this way and 510 pixels across that way. Full resolution image of a portion of M37. So that's that. Um, I also posted on the same Discord channel I think this was 2x2 binning, if I remember right. Why isn't this working? There we go. Of a region of M41. Same basic idea, except this is lower resolution. So, oh no, this is high res also 765 by 510. Okay. Um, so this is of a region around M41, and as you can see, this is raw data too. You can see that the field is not flat. See how there's all these sort of dark pixels over here and all these light pixels over here. So this is just raw data. You can see I've still got the bad columns and the bad pixels and everything else. But so again, these are still out of focus. I haven't messed with the focus at all. So it's sort of harder to see here, but you can sort of see a little fuzz around that. So yeah, not incredibly great yet. This is probably a faint star, but again, I'm seeing 15th magnitude stars here. So a lot of these stars were actually overexposed, which means they had a data value greater than 65,535. So that's extraordinary because these are pretty faint stars. These stars you can't really see with the um, unaided eye. So at a dark site, you can definitely see um, M41 if you know where you're looking. But if you don't, then you're not going to see it at all. It's a little fuzz, right? It's a collection of stars. It's a cluster too. But through the telescope with a 1 second exposure, man, I am overexposing. And that makes me smile. That makes me smile a lot because that means yeah, that's just absolutely awesome. These images, well, yeah, they're pretty good, pretty good. I also I didn't post this, but I also because the object of the day last night was M109, I actually took some images of M109 through this system last night. I could definitely see it. Definitely got some nice exposures. What I want to do, and maybe I'm going to start working on that tonight. I need to write some software to stack these images. The they're the tracking is bad enough that between exposures, there's a little bit of motion. And so I just have to write some software to be able to register those and then add them up. I'm really, really anxious to see what happens when I do that. To see if I can uh, uh, pull out any more um, stars and go even fainter. Um, I'm pretty happy with the magnitude limits that I have. Filtered, I'm seeing about 12 and a half magnitude, and that's with a moon. So I need to do it without a moon. So probably I can push it to about 13th or so um, with the filters that I have. And then, as I said, yeah, I'm seeing 15th magnitude uh, with no filters. So that's very, very awesome. That opens up a lot of possibilities. And you know, um, um, the quality of these um, images is is definitely um, 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 pro level for sure. So to do the kind of science I want to do and the kind of research I want to do, these are more than adequate. As I said, this um, camera that I have is sort of old school, but it is awesome. It is awesome, awesome, awesome. And so, I may have a small field of view. I might have, small sizes in terms of images, but the quality is definitely top notch, and that's what I need in order to do the kind of work I want to do. So yeah, pretty happy with these. Stay tuned. I will definitely keep you updated on um, progress in this project. Another thing that I just wanted to go through and maybe talk about a little bit tonight was just the different kinds of telescopes. Cheers. So there's basically three groups of telescopes. There are refracting, which uses lenses, reflecting, which use mirrors, and then these catadioptric telescopes, catadioptric telescopes that use a combination of mirrors and lenses. Uh, and so, actually, the kind of telescope that I have here is what's called a Schmidt-Cassegrain, and these are really popular because they're really cheap to make because of the optics. The optics are really easy to make. You can basically just punch them out. You don't even have to, grind and polish them or anything else. You can basically build a mold and melt some glass, punch them out. Um, there's a little bit of work after that, but not very much at all. So these are popular and widespread because they're cheap, right? I think I laid down like 1,200 bucks for mine, which I'm not. I mean, in my case, I'm not necessarily paying for the quality of the optics. I'm paying for the mount that can track. That was a requirement. If I was to get a new scope, the the thing had to be able to track. So, and this one does. It does it very well given certain conditions. So I'm happy with that. But a Schmidt-Cassegrain has an optical path like that. So here's the front of the telescope. So this is looking out to the sky or to your target, whatever it is. Here's your primary mirror. Here's your secondary mirror. And the lens in this case is sort of this glass plate here. And this glass plate gets rid of a lot of optical effects that this mirror and this mirror put into the images, but this almost flat piece of glass here um, corrects all of those things. It slightly changes the optical path such that uh, any of the problems that are created with the mirrors sort of goes away, and the results are absolutely astonishing. It's a nice flat field, and and awesome, very awesome. So uh, this primary mirror, as you can see, has a hole in the middle of it, which maybe you might think at first thought is sort of a problem because it's like, well, you're chopping out a lot of the light. But nope, that's not exactly true because your secondary actually blocks that hole. So no light is going to get to it anyway. And in fact, most of the area of your main mirror, of your primary mirror, is on the outside of that. So not a major loss. You always have to deal with the instrumentation that you have, and you know, you take into account all those kinds of things if you need to. So not a problem really. But yeah, these are sort of one of the cheapest and easiest reflecting telescopes that use a lens, so it's not exactly just a reflector. Uh, but these are really, really nice because they can be very, very short and compact, but still offer a pretty decent focal ratio at the focus. These primary mirrors are usually pretty fast. Their f ratios, can be maybe like f3, f2, f3 or so. And then the secondary mirror here is um, convex. See, the primary mirror is concave, right? It caves in. The secondary mirror is slightly convex, which stretches the focal length out a little bit more. So um, a Schmidt cast like mine um, has has a focal ratio of f10. So and yeah, that's a nice thing for pretty much everything. If you want to be looking at planets, if you want to be looking at galaxies, it's a good general purpose scope. Um, um, my other scope is a Newtonian telescope, which I will show you next. Newtonian is a pure reflector. And it sort of looks like that. So here again, the light from your target is over to the left. Light comes in, hits a concave mirror, which has a different shape. It's not a spherical shape, it's a parabola. And for reasons that I won't get into now, that has to be done. Otherwise, you have some weird um, um, optical effects at the focus. But then your secondary mirror is completely flat. It's a flat mirror set at a 45-degree angle, which bounces the light beam into an eyepiece that is on the side of the telescope. So it's called a Newtonian telescope because, yep, Isaac Newton invented it. He used a metal mirror back here uh, and a metal mirror here. They didn't have the technology, to deal with glass yet. So he had to actually cast his mirrors in, I guess, they didn't have steel, so it must have been iron, and then he had to polish it, so it looked like a mirror. It had a mirror surface, and yeah, very, very awesome. So this is the other kind of scope that I have, and um, the focal ratio that I have on my scope is f5.6. So it's a 10-inch diameter f5.6. So it's sort of a longish tube, right? I think the tube is 60 inches long, and it's about a 12-inch diameter or so. So you work it out how far the secondary has to be from the primary in order to properly reflect this guy into the eyepiece. That's sometimes a challenge. A little bit of math, no big deal. You get it eventually. As a 12-year-old kid, it took me several tries, but I figured it out. I got it. So I've got a bunch of holes in my scope, but who cares? Who cares? I'm at a dark site. No stray light. Anyway, who cares? So yeah, Newtonians are also good for pretty much everything. Pretty much everything. So there is the standard reflector, and there are, as you can see, many different kinds. I'm sorry, not reflector, refractor. Um, these use lenses. Uh, that's sort of the most basic, right? Is just sort of double lens, and it goes down to a focus, no problem at all. This produces, because it's acting like a prism, this produces all kinds of strange optical effects. So achromatics mostly aren't used. What are usually used are these guys. Yeah. And then usually what you have, and it's not actually even being shown here, of course, is an eyepiece at the other end. So let's see what these binoculars show. Of course, binoculars are also refractors, in that these are actually prisms that have a reflective coating on them. So here's your objective, your primary, as you can see, and light path is very complicated. That's why, binoculars can be as compact as they are, because they can bend the light around like that. But yeah, binoculars are pretty complicated pieces of equipment for sure. But yeah, to have them nice and compact so you can hold them in your hands, that's very awesome. Very awesome. Binoculars. Let's see, non-achromats. Some of these Wikipedia entries don't have any pictures, and when they don't have pictures, it's just very frustrating. Um, Schiefspieglers. Have you ever seen a Schiefspiegler? Go off on weird angles. Wow, that's a pretty crappy image there. Uh-oh. Anyway, this kind of telescope has two mirrors that are set off at an angle. Pretty pretty bizarre. Let's see if there's anything else here. Gregorians are pretty cool. Cassegrains are pretty cool. So this Cassegrain, except it doesn't have this sort of lens in the front. It just uses two mirrors, right? There's a primary and there's a secondary, and that's it. Put your eyepiece back here, boom, 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 you're done. It does have some strange optical effects, though. Oh, sure, sure. Perfectly fine if the focal length is long. You're just going to have you're sort of going to have to suffer with high magnification, unless you have a pretty big eyepiece, i.e., long focal length eyepiece. Which one of the German names? Schiefspiegler, is that the one? Yeah, Cassegrains. So Gregorians are kind of cool in that they have two concave mirrors. So they have a concave primary and a concave secondary. So that's kind of interesting. Mm, let's see. Oh, the Muxotoffs. The Muxotoffs are cool because they have a they have a concave primary mirror, and this, I guess you'd call it a concave corrector plate. And on the back of the corrector plate is a mirrored surface that acts as a secondary mirror. So it's a curved, convex secondary up here. It also has a corrector plate to eliminate a lot of the weird optical effects that are caused by, just a single concave primary mirror. So Muxatoft, you can always sort of tell a Muxatoft because you can sort of see it in this picture. That one's actually not too good. Let's look at this one. Sort of see it better, I think, here. See how the inside of this is curved? It's not, it's hard to see, but the inside of this is curved inward. So, maybe that's an inch or two from here to here in terms of depth. Kind of hard to see unless you see it in a reflection. Let's see if this one, let's see that any better here. Not really. It's hard to see that curvature, but it's actually curved for a reason, for a good reason. It's getting rid of these weird, horrible optical effects. So there are different kinds of Muxatovs. In fact, I I dare say that there is a different kind of telescope for every different kind of person on this planet. I mean, the combinations and permutations are almost endless. Uh, yeah, yeah, I totally agree that some of the Russian Maksitovs are very very awesome. I sure wish I had a friend who would uh, give me one of those. That'd be awesome. But as you can see, there are dozens dozens of different kinds of scopes, all sort of serving different purposes to a certain extent. Moxitov Casagran sort of looked at that already. Let's see. Let's look at the Schmidt cameras. Schmidt cameras are kind of interesting because it's got a main primary mirror down here, and it has this funky lens up here to get rid of all the optical effects. But in order to take a picture, in order to take an image, you need to stick it down here, and that surface is actually curved. So that curvature, I believe, sort of matches the curvature of this guy. Don't quote me on that, but it makes for very very awesome imaging photographs. Specifically the the Palomar Sky Survey images were all done on a Schmidt camera, where they had to put these big huge glass plates right here. There was some kind of an access door where they could slide it in, and yeah, I mean it was really like a major pain. And I'm pretty sure they were curved. Pretty sure they were curved. Um, but yeah, that was a major effort, and thankful for um, the POS plates. They were very very awesome. It was sort of the first one of the first surveys of the sky, sort of map of the sky, detailed map of the sky, which was just a photograph of the entire sky. And I think you could see. Don't quote me on this either, but I'm thinking that you could see down to maybe 17th, 18th, 19th magnitude. Don't quote me on that. Something like that. You can probably find out. But I think for now, I am going to exit this planet. It's been a good hour. It was fun talking about various things, astronomical and not. As I said, if you're watching this not live and have just sort of happened upon this channel, If you like what you're seeing, please subscribe, hit the notifications so you know when this is happening. This live stream does happen every single day at 2 hours UTC, where I spend a good hour, talking about astronomy, science, sometimes, um, go off on some tangents a little bit, talking about computers and Legos. But for the most part, um, this is restricted to astronomy talk. And yeah, like this if you like it. Don't like it if you don't like it. And make sure to share. Let others know that this channel exists. As I said, I'm going to be adding some new content here in the next few days. That is going to be recorded content. Hopefully you'll like it. I'm going to give it a try. It may not happen at all, since I can, pre-record. I can sort of see how nice it is before I send it out into the world. Um, but I think it's going to be interesting, and I think it might draw in a crowd, because I definitely want this channel to grow. I'd like to get a good crowd in here so we can have some interesting conversation regarding astronomy, and lots to talk about. I personally don't think that there isn't, um, you know, is is a reasonable end to any of the conversation or topics that we can cover. So yeah, let's do that. As I said, keep an eye out for some new content. Um, so yeah, I think I'm going to get out of here for now. Thanks for coming in. Definitely check you out again in a little less than 23 hours from now. So, all right. Peace out, everybody. Take care, and I will see you tomorrow. Cheers.